Hello. In one of my previous videos I've assumed that each elementary particle is actually a discrete machine that consists of discrete pieces. E equals reduced Planck's constant multiplied by W. W according to that assumption is not frequency but the amount of discrete pieces in particle. Reduced Planck's constant according to that assumption is not quantum of action, but quantum of energy instead. Quantum of energy that causes quantum of action. Each discrete piece of particle stores one of 6 possible directions in space: left, right, up, down, forward, back, and moves all the particle in corresponding direction of space with constant momentary speed in infinite loop. Link to that video is in the upper right corner now. Please watch it if you want to understand the assumption better. In another video I've described a contribution, the distance in meters per second that every discrete piece of photon contributes to its absolute motion. The more states photon has, the more directions it can move in, and the lower is the contribution of one discrete piece. Link to that video is in the upper right corner now. For simplicity, let's assume that particle can consist of instructions to move in one of 4 directions: left, right, up, down. Each particle is filled with those directions using random numbers generator. So we get different combinations of particles. Particle moves with momentary speed a meters per second. If particle consists of one discrete state, it can move up, down, left, right. 4 directions in total. Contribution of one discrete piece is A. The discrete piece navigates the particle all the time. If particle consists of 2 discrete states, it can move in one of 8 directions in total. Contribution of one discrete piece is A divided by 2, each discrete piece navigates the particle half of the time. Please note that if particle has 2 discrete pieces of opposite directions, those directions cancel each other and particle does not move anywhere. If particle consists of 3 discrete states, contribution of one discrete piece is A divided by 3. If particle consists of 4 discrete states, contribution of one discrete piece is A divided by 4. As we increase amount of discrete pieces in particle, amount of directions particles can move in increases and distance between those directions of movement decreases. All possible particle locations create a sequence of rhombuses. In 3D space there will be 3D rhombuses. Contribution of one discrete piece consisting of W pieces is A divided by W. I propose to give a name to the set of all possible locations of particles after 1 second of movement. Let's call them the discrete wave. We have wave maximums wherever particle can get and minimums everywhere else. The distance between the nearest maximums we can call the wavelength of the discrete wave. For new maximum to appear, 2 discrete pieces of particle should have opposite directions and therefore cancel each other. So wavelength equals 2 contributions equals 2A divided by W. Physicists use symbol lambda for wavelength. Let's use lambda d for the discrete wavelength. The amount of wave maximums in one direction of movement we can call the frequency of the discrete wave. Discrete frequency Fd equals A divided by lambda d equals W divided by 2. Why do I call those rhombuses discrete waves? Well, because according to my assumptions, these rhombuses describe the real behavior of matter. And modern science calls that behavior the wave behavior. So calling those rhombuses the discrete wave shows the connection with what physicists got used to. Also, they do have wavelength and frequency per second. Those are the key properties of wave. Please note that I did not make any new assumptions today. Everything I've described directly follows from the assumption that particle is a discrete machine. Also, please note that these waves are not waves of probability we've got used to, but are their cause. Discreteness according to my assumptions causes waves of probability. The wavelength of a particle and the discrete wavelength of a particle might appear to be strictly connected one with another or may vary depending on direction in space, for example. That will have to be investigated. Now I can only show 2 examples of how the discreteness of monitor can cause different types of waves of probability with different wavelengths. Our monitors are discrete and consist of pixels. Some amount of pixels for x-axis and some amount of pixels for y-axis. When we draw a line on discrete monitor, we can get into situation when line should be drawn between two existing pixels. In this case anti-aliasing is used, the nearby pixels are partially filled with required color. It looks okay when line's frequency is low, but leads to appearance of wave patterns that you can see on the screen now as line's frequency grows. As you can see, wave frequency grows as line's frequency grows. Everything is similar to wave behavior we know. If we use two sources of lines located near each other, we see longitudinal waves and their wavelength changes as frequency of lines grows. What is the connection between the discrete wave and the regular wave we all know? There are several ways to show the connection. One is normalization, or as they call it in quantum mechanics, decoherence. Predefined discrete structure of maximums normalizes due to errors, just as sum of coin tosses normalizes in normal distribution. Another way to show the connection will be described in one of my next videos. Also in next videos I will show how easy these discrete waves explain unexplainable de Broglie wavelength, Compton wavelength, and will show their connection with momentum and rest mass. Thank you for your attention.